Hello, this is the luckiest maths teacher in the world. Thank you so much for watching as we go through Pythagoras' theorem. So firstly, we have to understand what it is. So Pythagoras' theorem relates to right-angled triangles. So no other shape, no other type of triangle, only right-angled triangles. And what it does is it gives us a way to find the length of an unknown side in that right-angled triangle. So sometimes you will have, a triangle and you can't measure the sides. It could be a really big triangle of land or something like that. But this gives us a way to calculate unknown sides very, very quickly. So first we have to get the terminology right. So we look at the right angle triangle on your screen. You'll see that this side here is the longest side. Okay? So it's not a coincidence that this side is opposite the right angle. That happens in every right-angled triangle. By opposite, we mean they're facing each other. So the longest side in a right-angled triangle is always opposite the right angle, and it's called the hypotenuse. That's the proper name for it. So what we're going to do in this video is we're going to use Pythagoras' theorem to find the length of that longest side. So the other two sides don't have a special name, they're just the shorter side. So the two sides here and here, the ones that actually touch the right angle, they are just the shorter sides, no special name, but we usually label them A and B. It doesn't matter which you call A and which you call B. Just know that A means a shorter side, B means a shorter side. We usually label the hypotenuse as C. So make sure you always understand hypotenuse is opposite the 90-degree angle. Of course, there's always a 90-degree angle in a right-angled triangle. Otherwise, it wouldn't be right-angled. So what actually is Pythagoras' theorem? Well, Pythagoras' theorem is that A squared plus B squared equals C squared. So what does that actually mean? What it means is if I take this side and square it, and I add these two up, it equals the square of this side. Another way to think of it is that if I make the side of the right-angled triangle into a square, if I make a square here and I make a square here and I turn this into a square like that, this square is equal to the sum, so the area of that square, is equal to the sum of the area of this square plus the area of that square. Okay, so what we're actually doing is we've come up with a formula, and now we can use that formula to find the length of an unknown side. And in this video, as I said, we'll just look at the hypotenuse. So if you want to copy this down, please do so now, because I'm about to go to a new screen and do some examples. So we'll look now at finding the hypotenuse. Remember, the hypotenuse is the longest side of the right-angled triangle. So we'll just look at finding the length of that side. So we know that A squared plus B squared equals C squared. A and B are the shorter sides. C is the longer side, the hypotenuse. So to find what it is, we can just take the square root of each side of this equation. We get C equals the square root of A squared plus B squared. So all you need to do is substitute into this formula here the length of A and the length of B. Easy as. Let's look at an example. So if I have a right-angled triangle like this, so of course this is the longest side, the hypotenuse opposite the right angle. So let's say the lengths of these sides are 3 and 4. So that means that the length of the hypotenuse, C, is going to be the square root of 3 squared plus 4 squared. So make sure you understand 3 squared, this here doesn't equal 6, it equals 3 times 3, which is 9. 4 squared doesn't equal 8, it's 4 times 4, which is 16. So C equals the square root of 9 plus 16. 9 plus 16 is 25. So it's just the square root of 25, which is 5. So if I draw a right-angled triangle, and let's say the shorter sides are 3 and 4, then the longer side must be 5 units, whatever that is, centimeters or whatever, okay? So I'll rub this off and go through another example. Okay, so let's have a go at this one. So I want to find the longest side. Again, I'll call it C. So we just go C equals the square root of the sum of the squares of the two shorter sides. Of course, we're adding here, so it doesn't matter if I write it the other way around. It wouldn't matter if I wrote the square root of 6 squared plus 9 squared, because the order you add things doesn't matter. Now, please don't think that you know the answer. Think, okay, 6, 9, this must be 12. Well, it's actually not 12. We'll use our calculator for this. So 6 squared is 36 and 9 squared is 81. If you put that on your calculator, you get 117. So C is the square root of 117. Now, this is called exact form. So the square root of 117 is irrational. So if you look at its decimal, it goes on forever and ever and ever, but there's no pattern to it. So we can write the square root of 117. That's the exact number. But that may not make sense to a lot of people, so sometimes we round it instead. A lot of people might not know what the square root of 117 actually is. Does that equal 15, 10, whatever? So sometimes we round it. So if I round this to 2 decimal places, it's 10.816, so I round it up to 10.82. And it's just 10.82 units. So if these were both, say, centimetres, then the answer would be 10.82 centimetres. And this is rounded answer. So just make sure you read the question. If it asks for exact form, you'll give the answer as the square root of something. And if it asks for rounded form, you'll have a decimal in there as well. All right, we're just going to do one worded question. So please copy this example down if you need. So we'll have a go at this question here. So we're talking an isosceles triangle, base 24 centimetres, perpendicular height 9, and we want to find the lengths of the other sides. So you're probably looking at this now and thinking, well, what's this got to do with Pythagoras? Yes, that's a good thought because this is involving isosceles triangles. It didn't say anything about a right-angled triangle, and we know Pythagoras has to involve right-angled triangles. But whenever you're given a worded problem like this, start by drawing a diagram. So we're going to start by drawing an isosceles triangle. So we know from isosceles triangles, they have 2 equal sides. So we're told that the base of this is 24 centimetres. We're told the perpendicular height, so that's where the right angle comes in, is 9 centimetres. And we want to find the length of this side here and this side there, but they're equal. So what I've actually done is I've turned this into a right-angled triangle problem. I now have a right-angled triangle here, and so I can use Pythagoras. Now, a property of isosceles triangles is that this line here, perpendicular, it bisects, it cuts the base in 2. So it'll be 12 centimetres from here to here, and it'll be another 12 centimetres from here to here. So what I actually have is a smaller triangle. It's right-angled. The base is 12 centimetres. The height is 9 centimetres, so I can easily find this one here. And it will just be the square root of 9 squared plus 12 squared, which equals the square root of 225, and you can use your calculator if you need it, equals 15, and it's in centimetres. So we used Pythagoras to help with a problem that involved another type of triangle, but we can only apply this theorem to right-angled triangles. It just happened that in this question, we could divide the isosceles triangle into 2 right-angled triangles. That is a rule. You can do that with any isosceles triangle. Okay, I hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.